So to start off with generators, what is a generator in the first place? So we're familiar now with many kinds of sequences. So from the first art, we had yung strings. This is the first kind of sequence we were familiar with. A string is a sequence of characters. So aside from that, we also had tuples. So a tuple is a sequence of different values. Then aside from that, also in the first arc, we had frozen sets. So frozen set does not care about duplicates or ordering. So something like this will just be 1 and 2. Now for the second arc, the kinds of sequences that we've seen so far are yung lists. So a list of numbers like this, as well as an actual set. So a frozen set that you can modify. We went over this last week. So a set, if you do it like this, you get back this set. So all of these are sequences that we have seen so far. Today, we're going to look at one other kind of sequence, and that is what we call the generator. So what is this generator? It's a sequence that you can only use at most once. So when it comes to generators, there's only one kind of operation that you can mainly do with it, and that is getting the next element. For other sequences so far, like tuples for example, there are a lot of things that you can do with this. So for example, you can index it somewhere, you can slice it, and you can add it with other tuples, and so on. So if you have a generator, the only main thing you can do is get the next element. And for that, there's a function called next that gives you the next element of this sequence. Okay, if there are no more elements, there's an exception. I guess it's better if I actually show you what's happening here. So to make a generator, the main thing that you do is you make a comprehension. So I have a generator. I have a generator here, and what I have is, oops, there. Let's say we have x for x in range 5. Something like this. So these are the numbers from 0 until 4. If I did this using tuple then x for x in range 5, what I would get from this would be this tuple over here. But for this generator, if I define it like this, without any keyword before the parentheses, if I look at gen, it's what we call a generator object. So this is what we call a generator. And the only thing that we can do here is get the next element of this generator. So calling the next function with gen as its input gives us the first element of this sequence over here. Then if I do that again, I get the next element. So 0, 1, 2, 3, 4. Then if I call next again, I get yung stop iteration. So notice first that whenever I call the same function with the same input, I get different results. So if you remember from our first lecture about imperative programming, the main quirk of imperative programming is this behavior. If you do the same thing, it's possible to get different results. So yung generators are a concept for imperative programming. Okay, so we'll go over this. Okay, so I showed you that one way to make a generator is with a comprehension like this. The other way, or the more common way, is this. So inside a block under def, use the keyword yield. So what that looks like is something like this. So let's say I have, this looks like a function call, and yeah, this is how you define a function normally. But what I do inside here is, instead of returning some value, return something, What I'll do instead is I'm going to use the keyword yield. So yield, then some string. Let's follow this one here. I'm going to yield something, then yield another thing. So what that does is, if I call this will give me a generator. So you can think of this function as yielding these elements over here. This itself is the generator, and it yields these values over here. So if I assign that to a value, this is now my generator, and let's look at it again. This is a generator object. Then if I call next on it, I will get each of the values that I yield in order. So the first string that I yield is Momoy, so that's the first thing I get. If I call it again, I get the next string that I yield. So if I do that again, just like with any other generator, if you run out of elements to yield, you will get a stop iteration error. Okay, so this is how you define a generator. So by calling this function over here, you're getting this generator object. So if I have gen1 is members, this will now be a generator of the values over here. Now note that this is going to be separate from if I made a second generator. So let's say I make two different generators over here. This is the first one, and this is the second one. If you notice, they're at the very end here. They have different digits at the end here, which means that they're different generators. So if we try to get next, then gen1, I'll get the first value. If I call next again, I get the second value. Now if we move on to the second generator, it also gives us those same values. So next of the second generator is the first value, and if I call that again, that gives me the second value. So calling next on one generator does not affect the other generator. Okay. So once I call next twice for the first generator, calling it again for the first generator is going to give me a stop iteration. So you can't retrieve yung values that you've already generated. Okay. So this yield over here, this keyword yield, this is kind of like return, but not really. For return, what happens is whenever you return, let's say define, I am going to define a function, then here I'm going to return a value. Let's say I return 1, then here I print hello. So whenever I call f, I only get the value here. I don't see this print out over here. If I did this instead, print hello, return 1, then I remove this line over here. If I start with the print first before returning, and I call this function, I get the print out first before the return value. So return immediately stops the function if return already immediately stops the function. On the other hand, yung yield does not do that. So for example, let's say I have this f, then I yield 1, then I print hello. So if I try to do this, what I'll get is calling f will give me a generator. So let's assign that to a variable. If I call next of gen, what I'll get here is the first thing that it yields. So as you can see here, it's giving me the value 1. That's from this line over here. And what actually happens is it doesn't actually stop yung execution ng f over here. Or it doesn't exit from the execution. It just stops it temporarily. So if I call next of gen again, I'll get the hello, then that's where I get my stop iteration. So it pauses here before it continues when I call next again. So if I define f like this, yield 1, print hello, then yield 2, then I assign that to a variable. So next of gen is going to be 1. Then it pauses here first before it moves on to the next value to yield. So if I call next of gen again, that's when it prints out the hello and yields this value over here. So it does this first before this block over here. Okay, so Python already knows that whenever you put yield inside a function, it knows that this here is going to be a generator. So whenever you call that function, it will give you a generator like this. Okay, so we've already done this. For now, we recommend that you only use yield if you want a generator. Try not to use return yet. So don't mix yung yield and return, since you might get unexpected results from this. Okay, so don't use yield and return in the same function. Okay, so what else can we do with generators? Well, since generators give us a sequence of values, so here I'm going to yield the same strings. Then let's get the others as well. So I have this generator, and I can assign it to a variable like this. Since this is a sequence of values, what I can also do is wrap that around any of the other sequences we've went over. So for example, if I wrap this f around a list, what I'll get now is a list that contains these values over here. So you get a list with the first value, the second value, and so on. So you can also do this with tuple. If I wrap this around tuple, I have those same values but inside a tuple. Same thing with set and frozen set. Okay, so the point of generators, or the main thing about generators, is that you can only use them at most once. So let's say I have gen is equal to f. So gen is now my generator. If I try to wrap that around a list, I'll get the list here. Then if I try to do that again, list of gen, I'll now get an empty list. So the reason this is happening is because in this first call over here, this is already consuming the values of this generator. So you can only consume those values at most once, which is why this list is full, but this second list is empty. Okay, so this is not the case if this was any other sequence we've seen so far. So if this was a tuple instead, doing this twice would give us the same results. But since we're working with a generator now, like this, we can only use this at most once. So be careful about that. Okay, so what if we want to go the other way around? So we know that we can wrap list, set, or tuple in order to get that specific object. What if we want to get a generator instead? Well, if you have a list, then you want to turn that into a generator. What you can do is use iter. So this stands for iterate. You want to iterate over the elements of this sequence over here. So if we have iter, then this list over here, that will give us what we call a list iterator object. So this is kind of the same thing as a generator. You can call next on it, for example. So let's say I have this is equal to iter 1, 2, 3, 4. Then I get next of gen. This will give me the first value, then the second value, and so on. So just like with other generators, it also gives you a stop iteration if you run out of values. Okay, so just to show that this indeed behaves like a generator, let's try to wrap that around a list twice. So for the first list, this generator gets consumed by the first call to list. Then for the second call, it's already consumed, so it generates no values over here. Okay, so yung original list, let's go back here. If this was a variable, 1, 2, 3, 4, then I made this generator here. This list will still remain the same. This isn't a generator, so this will remain untouched. So if I get list again, its values are still there. So only for generators will the values get consumed. Okay, so what's the point of using these in the first place? If we already have tuples, lists, sets, and so on, why do we even have generators? Well, for one thing, we've already been using generators actually. So whenever we do stuff like this, we have this comprehension inside a list, or let's say we have a for loop like this. For this first one, if I have a for loop or a comprehension, x for x in range 5, what's actually happening here is I'm calling list, then here I have a generator, x for x in range 5. So something like this. So what's actually happening here, whenever I write this, is you have a generator that you make over here, then you're wrapping that around a list. So you're putting a generator inside the list function. That's what's happening when you write this syntax over here. Okay, how about for loops? So let's say we have our generator from a while ago. We can also use this in a for loop. So for value in f, let's say we print out that value. So this is like any other sequence, so we can iterate over that sequence. So we can use a for loop for that. For each of the values in this generator, we can print out the value that we get over here. So again, generators are one-time use. So if I have gen is f again, then I do for value in generator, I print out that value, I'll get these values over here. But if I do that again, I'll get nothing this time. So even for loops, you can only use those values at most once. Okay, so whenever you have a for loop like this, what Python is actually doing is something like it assigns value to the first element of the generator. Let's make the generator again. So value is next gen, then it prints out the value, then it does that again. So it only stops, it only stops whenever it runs out of values to look at. So for the next value, it's out of values. So once Python reaches a stop iteration, that's when it exits this for loop over here. Okay, so this is one of the main uses of generators. We'll see some more uses later on. Okay, so again, if I have something like this, whenever you iterate over this for x in gen, print a, then x, I'll get a as well as each of the values here. Since this is a generator, you can't use it again. So if you try to do something like this, you won't get any values anymore. So make sure, if you want to actually print this out, you redefine the generator over here. Okay. So because generators are one-time use like this, what we usually recommend is don't store them in a variable like this. So just so you don't get confused if stuff like this happens. So whenever you define a generator, let's say you have something like this, yield some value. If you're going to use this generator, use it as something like this. Call the function g, instead of assigning it to some separate variable like this. Okay, so how about this example here? So here, what I basically have is some function. So sum squares, then n. Then what's happening here is for each value from 0 to n minus 1, or in range n, I'm going to yield b squared. So if I try to call this will give me a generator, since I have a yield keyword over here. So whenever I call next for that, I will get this first value, then let's use a for loop instead. For value in sum squares, then 5, print value. So this will give me the values, the squares of 0 through 4. Okay. So if we do that, let's print this out. If I print this function call, what I'll get is a generator. So remember that whenever you actually call a function that behaves as a generator, what you'll get back is not a value, but the generator object itself. So if I do this, I will always get back a generator. Now on the other hand, if I put an asterisk before that, or if I splat this generator first, what I'll get are the actual values. So this makes a generator. This gives you the values in that generator. Okay. So for this, you can also write this as a comprehension. So it's the same as any other comprehension we've made so far. So this is v squared for v in range 5. Range 5. This is the same thing as this thing over here. For v in range n, you're yielding v squared. So these two do the same thing. They make a generator. Okay. So this thing over here is what we call a generator expression. So this part is an expression, and that evaluates to a generator. So because we have an expression like this, we can also wrap this around other sequences, as I've shown a while ago. So we can wrap that around a list. If you do that again, you no longer have the values. Then if we define that again, we can have set of g. That will give us this set over here. Okay. So since you write this using a comprehension, you can use anything about comprehensions that we've covered so far. So for example, you can have chain comprehensions. Let's have this first, x and y for x in range 5, for y in range 5. So if I try to print out all of the values in that generator, I'll get all of these tuples over here. So this is the first one, the second one, and so on. So this is a chain comprehension. You can also have comprehensions that depend on each other. So for x in range 5, for y in range x, for example. So here, if I define the generator like this, and I print out all of the elements, I'll get something like this. So now, these will depend, the second comprehension depends on the first comprehension here. Okay, so let's look at something like this. So we want to make a generator that gives us the numbers from A to B. So range already does this for us. The question is, how do we make our own? So how do we make our own range? Well, here, what we want is A until B minus 1. So if we define my range of A until B, we have to somehow make all of the numbers A until B minus 1. Well, what we can do here is we can start with A. So I can write this explicitly as number to yield. Number to yield is equal to A. then what I do here is I want to keep yielding values until b. So actually, what I can do is for x in range, well, we can't use range, so let's go back to here. Value to yield is equal to a. Then I can yield a, of course. So yield a. Then I have to increment that. So value to yield plus equals 1. And we check here, if the value to yield is already equal to b, then we can already stop this function over here. So once we reach this, we're already done. So add nothing here. So we keep doing these steps over here. This is value to yield. We keep doing this, value to yield, until we reach the ending point of this generator over here. Okay, so how do we actually write this out? So one way is, just like most of the functions we've made so far, we can define this recursively. So for all of this, what I can do here is, let's say we base off from this a over here. So if a is already equal to b, then there's nothing left to do. So let's put nothing here. Otherwise, we still have to yield the value a. So let's yield a. Then let's call my range then a plus 1b. So you're yielding a, then you're making this recursive call over here. Okay, so let's see if that works. For x in my range of 1 until 10, let's print x. Okay, so here it is only giving us the value 1. Okay, this is, we're not doing anything to this generator. So we have to iterate over this generator. So for each value in this other generator, this is from the recursive call, what we do here is just yield that value. Okay, so now if we call this, we should now get the values 1 until 10 minus 1. So this would be a recursive definition. This is your base case, and this is how you use the recursive call. Okay, so just like for any other function, you're still free to use wishful thinking, especially recursion, when it comes to making your own generators. Okay, so this is just to demonstrate how we make our own generators. If you want a range of values, just use the built-in range function. Okay, so what else can we do? Let's say we want a generator that gives us 2 copies of each element. So define duplicates, then some sequence, then we want each element of that sequence twice. So for this, what we can do is, well, what we essentially want here is, let's get the first value, next sequence, then once you get that value, we want to yield that. Then since we want 2 copies of that value, we can just yield it twice. So something like this. Then after that, we get the next value, then we yield that value twice again. So yield value, yield value. And we keep doing this until we're done with the sequence. So this is the unrolled version. If we want to roll that back up using a for loop, we can do for value in sequence. Then all we have to do is yield that value twice. So yield value, yield value. So there, that's how we make this generator. So let's say my sequence is 1, 2, 3. If I have for x in duplicates, of that sequence, let's print out x. So now I have each value of that sequence duplicated. So this is how you would make that kind of generator. So something like this. Okay, what else? So here we have a sequence as well as some number, and we're going to enumerate starting from whatever number we give it. So this is just like the enumerate function. Okay, so how do we do this? Define enumerate from, then here I have numbers or some sequence as well as some starting value. So what we want to do here is we want to get the first element of the sequence. So x is whatever the next element is. So something like this. And we want to print out that value as well as the index, or the other way around. The index, then the value. Then for the next iteration, let's increment yung I, then get the next value over here. So we print out I and x again, then we move to the next iteration. So I plus equals 1, x is equal to next sequence, then print I and x again. So what will happen is something like this. So this is what happens in each iteration until we reach the end of the sequence over here. So we can write this as a for loop. So for x in sequence, what I'll do is basically these steps over here. Print I and x, or instead of printing, what I want is to get both the index and the value. So let's yield that instead. Yield the index and the value. Then increment the index by 1. And there. This is already the rolled version of all of these lines over here. So we don't need all of these lines anymore. So that leaves us with this. If we have, let's try printing out enumerate from 1, 2, 3, and I want to enumerate this starting from 11. So if we have that, we have the first index accompanied with the first value, then the next index with the second value, the third index with the next value. So this is how we make this generator over here. So something like this. Okay, so this is the same thing as yung enumerate function. So if we have enumerate, that also gives us the same thing over here. Okay. Alright. So from the for loop lecture, we had this exercise over here. So you want to find the number of consecutive letters. So how we did that for loops was we looked at each pair of consecutive letters at a time. So this M and this I first, then we move to the I and S, then so on and so forth. That's how we did it using for loops. And actually, we can also do this with generators. So define the number of equal consecutive characters, consecutive, of a string. What we do here is we check each pair of characters. So the way we did that for loops was for I in range, length of S minus 1. We check if S of I and S of I plus 1 are equal. So if S and Si is equal to Si plus 1, we increment some counter by 1. So this is how we did it for using for loops. If we want to use generators for this, remember that generators or comprehensions look very similar to for loops. So we can write this as at least this part over here. This is for I in range length of s minus 1 if s of I is equal to s of I plus 1. So something like this. What's left is what we actually put as the value over here. So whenever we want to count something, one way to do that using comprehensions is for the value, we put a 1 over here. Then what we do at the end is get the sum of all of those. So what this is doing is it's counting the number of i's for which this property is true. That's what this comprehension here does. So we can put that inside return, and we don't need any of these lines anymore. Equal consecutive. So something like this. So if we have equal consecutive, let's say the string from a while ago, this will give us the 3 pairs of consecutive characters over here. So you can use this pattern if you want to count the number of instances of something. Okay, so that's what sum does. Sum, as the name suggests, this gets the sum of everything that you give it. So the sum of this sequence is 15. Okay, so there are many other functions that do something similar to this, and we've already encountered a lot of those functions before. So these are those functions. Okay, what else? So here we have a string, and we want to reverse each of the words over here. So define, let's say we want to get the words in reverse. Then we have a whole string over here. For this, what we can do is we get the first word, then reverse that, the second word, then reverse that, then so on. So one way we can do this is we keep track of a list of the reversed words. Then for each word in this string, let's say we get the first word is however we get a word from this string. So for now, let's use indexing for that, although this isn't really right. This is the first word, then I will append the reverse of that. Reverse, then word. Then I do that again, S1, then do the same thing. Append reverse of the word. And so on until I reach the end of the string over here. So this dot join, then these reversed words over here. So something like this. Each of the iterations is over here. Alright, so how do we actually write this properly? So Python has another function that can give you the words inside a string like this. And that's split. So let's say I have hello world. If I use split on this will give me a list where each of the elements is one of the words in that string. So note that by words, I mean they are separated with spaces. So if I have a comma here instead, then I try to split this, I will still get a single string. So if you want to split them by comma, what you have to do here is explicitly write the string that you want to split them with. So if I split them with a comma, that's when I get the words separately here. So if you want to split using spaces, you don't put anything here, or you can explicitly write space over here. If you want to split with anything else, you have to explicitly indicate that. Okay. So once you have the words, you can just get the reverse of each word. Then you can join them at the end like this. So that's how you do this particular example. Okay, so here now we have a string and we want the suffixes. So from one of the previous lectures, what we did here is, again, a suffix is a string that ends at the end. So we basically want to find all of the strings. For example, for A, B, C, D, E, we want A, B, C, D, E, then B, C, D, E, then so on. If we look at how these are indexed, that's the original string, then 0 onwards, that's the original string, then 1 onwards, then so on and so forth. So if I want to actually get these suffixes, define suffixes, then some string over here, what I can do is, if the only thing that matters here is my starting index, what I can write here is S, then slice it like this, I, then onwards, for I in range length of S. So something like this. Okay. Or I can write this as for string, or for some string in this generator over here, I will yield that string. Okay. For here. So if we try to get the suffixes of some string now, I should get the suffixes that I want over here. Just like this. If I also want the empty string, what I can do is, here, I can add a +1 over here to represent the empty string. So if I do this, now I have the empty string at the end. This will represent S, the original string. Then we index that starting from its own length. So length of S onwards. So this will give us the empty string over here. Okay, so what else? A generator that gives us the partial sums of this. So the partial sums here are, you start with 0, then you add this 3. This gives you the element 3 over here. Then from that 3, you add on yung 1. So 3 plus 1 is 4. So you give the 4 over here. Then on top of that 4, you then add this other 4. So 3, then 3 plus 1, then 3 plus 1 plus 4. So to make a generator for that, partial sums, then sum sequence, what I can do here is, well, I need to keep track of what my current sum is. So current sum is equal to 0. I have to yield 0 at first. That's the first thing we yield for the empty sequence. Yield the current sum. Then for each element in that sequence, for x in sequence, what we do is we add x to the current sum, plus equals x, then we yield the current sum. So if I do this, let's say list, then partial sums, let's give it range of 10. So this will give me the partial sums of this sequence over here. Let's use 1 to 10 plus 1 instead. So something like this. 0, 0 plus 1, 0 plus 1 plus 2, 1 plus 2 plus 3, then so on. And the way you write that is something like this. So you yield 0 at first, then for each element, you add that before yielding again. Okay. So what else? What if this time you only want to do something to some particular elements? So define all events, then some sequence, we already know how to do this with a comprehension. So x for x in sequence if x is even. This is how we did it using a comprehension. And actually, this is already what we have to do. So we can, for value in something like this, yield value. Yield value. So if I have print all evens, then let's give it the range from 0 to 20. This will give me all of the even numbers until 20 minus 1. So pretty much the same thing as a comprehension over here. Okay. So far, you may have noticed that when it comes to generators, they're very similar with comprehensions and loops. So this is something that we'll go over later. We're going to piece together how these three things are related to each other. Okay, so for now, we can already see how generators or comprehensions are actually related. So, for example, here, whenever we have this tuple comprehension over here, what's actually happening here, as I showed a while ago, is whenever we write tuple x squared for x in range 5, what's actually happening here is you have a generator, x in range 5. Then what you're doing here is you're just wrapping this around the tuple function. So there's an extra parenthesis over here. Okay, so explicitly, we can write this as, we assign this to a variable, then we use that inside the function. Here, then we wrap that around tuple. So that's what's happening whenever we have a tuple comprehension like this. Okay, so the tuple consumes the generator, so G is no longer there. If we do this again, there are no more elements in G. Okay, so all of the comprehensions that we have been using so far, like this, are actually just generators. We're making a generator, then we're wrapping that around one of these functions over here. So same thing for the other kinds of comprehensions. So for frozen set, for list, this list over here is just the same thing as this. Okay, so this is just nice syntax for writing this out. Okay, so same thing with the other sequences. This is also a generator. This is also a generator. Okay, so even though these are the same thing, we still recommend using the nicer syntax. That's what they were made for. So use this if you want to make a set using a comprehension, and use this if you want to make a dictionary using a comprehension. Okay, so how about this? Here I basically want to pair up yung 1 with each of the values here, then 2 with each of the values here. So let's say Cartesian product of two sequences. Sequence 1, sequence 2. Well, how we usually did yung Cartesian product is for x in sequence 1, for y in sequence 2, then we just yield over here, yield the pair x and y. So if I have Cartesian product of, let's say, I put this inside a list, Cartesian product of 1, 2, and 3, and 4. This will give me all of the pairs where the first element is from the first sequence, the second element is from the second sequence. So something like this. So this looks right, and for most inputs that you have, this is going to be right. But there is one special case where this might give you the wrong answer. And that is if you have something like this. I'll write it like this. So if we now have, let's go back here. Here I'm going to use G instead of the tuple 1 and 2. So if we have this, this still works. Because we're just using each element once. This is for, we'll go back to this in one of the later examples. But yeah, for this particular example, doing this is fine pala. You can use a double for loop as long as you're using each element in each sequence at most once. Okay, so when does this actually go wrong? So this will go wrong if, let's say I have this 1 and 2 is paired with each of the elements of the second sequence. And you have to use each of the elements inside each iteration of the outer for loop. So in that case, if I do this instead, what will happen here is, if I have 1 and 2, and I put G over here, what will happen here is I will only get the first two values over here. Yung 2, 3, and 2, 4 are no longer there. And the reason for that is for each iteration here, you're already consuming sequence 2. So what you actually have to do is something like, just make sure that this is not a one-time use sequence. So you can turn this into any other sequence, for example, a list. Then here, you can write this normally. So now if we have the same call from a while ago, this is a generator, and if we call this again, we will now have all of the values that we want. So make sure the sequences that you're working with are not generators, especially if you plan on using those sequences multiple times. Okay? Alright. So there are some other ones over here. Python also has built-in functions called any and all. How that works is for any, if any of the values that you give it is true, let's say there are a bunch of falses over here, but there's a single true, this will give you true. But if all of them are false, this will give you false. So if we want to make our own, okay, so define our own any, my any, then subsequence. What we want here is, we want this to return true if we see that one of the values here is true. So for x in sequence, what we can do here is if x, or you can also write if x is true. This is the same thing as just writing if x. Or yeah, if x is true, then that means you've already seen at least one instance of true. And that's all you need if your function is n. So return true, return true. Then if we go over the entire sequence and we don't see a single true, that's when we return false here. So my any, then the same sequence as a while ago. False, false, false. This will return true. Then if all of the elements were false, that would give us false over here. So that's how we make our own any function. And for the all function, I'll leave that to you. Okay. So yung any and yung all, these are what we call short-circuiting. So for example here, for this call to any, how this works in Python is once it sees a single true, it's no longer going to look at all of the rest of the values here. Even if there are some other truths over here, once it sees a single true, it doesn't look at the rest of the sequence, which can be efficient in some cases. So once it sees this, it no longer looks at the rest of the things here. Okay. So that's any and all. Okay. So as a sanity check, you can go over this exercise here that uses yung any function. I guess it's pretty obvious what this function is trying to do, based already on the function names here. So yeah, that's generators. If you want to go a bit deeper, there's this article by one of the DCS alumni about how generators work at a lower level. So we can look at this article if you want to see how generators actually work in respect to other kinds of iterable things in Python. Okay, so that's generators. Any questions for this? No questions? If none, that will be it for